This is a podcast for Rev4 engineering. We're going to be talking about all things that face engineers today, especially as regards tolerance analysis, the solutions that are out there, and how we can free ourselves up to have more time doing actual engineering instead of just crunching numbers manually. And so let's start by talking about who we are. Who is Rev4 engineering?
Well, hi, I'm Subrat Devnath. I'm the president of Rev4 Engineering. Today we have with me David Jolly, our vice president, and our chief engineer joining us today. Good to be part of this. Well, I mean, first of all, engineers, what do? We build products and we try to, bring beautiful products to market. The goal is to bring products to market as fast as possible. So we are always looking for ways to cut down the engineering time needed to build and manufacture a product. So we are always looking for new software, new ways, shortcuts to do that. Well, in that process, just building anything is, it has to work in real life. It cannot break down when it gets used by the users of any system or any parts. So we have to make sure that everything fits together properly. Everything works together properly. So this fitting of parts is called tolerance, and the calculation or tolerance analysis takes up so much time, from our day. So we have an exciting product to solve that problem, Tolerance 360 product. That's why we are here today, to talk about that and how it can save so much time from our work day.
Usually an engineer takes up to 3-4 hours. Like if it's like a product like a medical device, it might go up to 3 or 4 hours to calculate the numbers, doing it manually, and with and the expertise that should be gained from gd&t comes up in years of experience. So but with a good tool, it might not take that much time. We can have all the numbers. Nowadays we have everything digitally, so we can just get the numbers added up according to the rules that are already set by the engineers, and then we can do it fast with a good tool, like a tolerance analysis tool.
So over the course of a project, that 3 or 4 hours could add up to hundreds of hours spent just making these calculations.
Yep.
Yes, exactly. And if I can interject, so yes, doing the calculation using 3-4 hours the first time, that might be fun and challenging, and as an engineer we love challenge, right, to solve a problem. But a couple of things, that calculation, it's not just once and done. You have to do that calculation over and over during the R&D phase, because we change our design 50-60 times sometimes to make sure everything is right. So you have to do that calculation 50-60 times. So first time might be fun, and then it is not fun anymore. It is especially not fun. Let's say that you have 500 stack up calculation, and this 500 calculation uses, let's say, 5 to 10 parts on an average, right? But you made a change in one part, right? Happens, but you don't know what 500 calculation out of 500 calculations, what calculations uses that part. So now you have to go and look for every calculation that you have done and you have to update. I mean, that is, I have heard a client telling us that a team of 10 engineers took 3 days to find and update one change that they made. That one change that takes 3 days can be done in 1 second using our software. That's, using Tolerance 360 software. The exact feature is called auto update. So basically, anytime there is a part change, say it's like once and done, you do the calculation once, and then the software can memorize that and update it whenever it is necessary. Again, you can stop the update if you want to, if you don't want to auto update, but auto update is our default behavior of the software. That's why we are here, because that feature alone can save hundreds and hundreds of hours, if you have an engineering company manufacturing product fast.
Awesome. And it gives engineers more time to do creative things and design things than just crunching numbers by hand.
Exactly. And, calculations and making sure that tolerances are right is fun. But really, I've talked to a lot of engineers, nobody really, everybody tries to kind of avoid it a little bit. It can be daunting. That's what I'm trying to say. Some calculations are easy. If you have 2 or 3 parts, it's easy. But if you have 10 or 15 part stack calculation, and you have to consider the effect of heat and force and wind, real life scenario, doing that calculation with all the parts, it can get complicated and cumbersome, really. That's where we come in, because the software can help.
How did you guys come up with this idea? I mean, it seems so straightforward now. Like, you're saving so much time. You're making the process more efficient. You're speeding things up. You're saving money. But how come no one's done this before? How did you guys decide to do this?
Actually, we're not going to get Nobel Prize by saying that we came up with the idea. The idea is not ours. We saw the problem. So Rev4 Engineering, our parent company, Analysis Express, we have been in business for 15 years. We have worked with many clients, many large companies. We have solved many difficult problems for many companies. So throughout that process, we came across this tolerance problem, and we saw that nobody is looking at the problem from a data standpoint, So, our parent company, Analysis Express, all we did was data analytics, right? So when we came across this problem, we took this problem from a data standpoint instead of 3D CAD, 3D modeling, visualization, the CAD and graphic design, much, there are a lot of softwares that does that, and a lot of software that does a really, really great job in visualizing. If you're building a part, what it's going to look like from top to bottom, rotating, upside down, maybe some visualizations with heat, force, liquid, or motion, like a door, like how it swings, that kind of standpoint. But we look at the world from a data standpoint, So if it is a part, if it is a door, let's say, you have, at least 4 major points, the height, width, So we look at it from a data standpoint, and that's where our software depends on the gd&t standard. So what gd&t is a language or translator to translate the 3D world that you can put it on, pen and paper, you can draw, and translate that 3D world into a 1D, 2D, pen and paper kind of world. The nice thing about that is it is accurate, and you cannot mess around. It is very, very accurate, and it is very low cost technology that has been invented 50, 60 years ago, matured at this point, and you can give this paper drawing, to anyone in the world, and it is going to be translated the same way. So that's the beauty of it. That's what we use in our software. We look at software from a data standpoint. So we try to solve the problem from a different way than any other company.
What are some of the problems that we see with common tolerance analysis methods today?
There are a lot of solutions out there, software solutions. Also, a lot of companies come up with internal tools that they've developed to help manage this. And, like we said earlier, those are all, good solutions, but they don't connect the whole process together from your initial design to manufacturing and quality in between. So our tool helps kind of connect all those points, all those dots of the process. Because there's great tools that do the actual analysis. There's tools that that produce first article inspection reports, but our tool kind of handles everything. And it's not like a simple Excel template tool, but it's also not as complicated as some of the 3D tools. We're kind of in between the middle. And we feel like that gives a little bit more flexibility to the engineers to look at the whole process from beginning to end and find ways to save that time and find designs that might save money on and be a better design overall versus having everything split up into different buckets. So that's one of the more common things that we see with tolerance analysis tools and methods today.
Exactly, and I'm going to add on to that. So there are 2 broad categories of solution in the market. You have, on the one end, you have basically manual solution. Basically you have nothing at all. You're doing the calculation with pen and paper, maybe Excel, and you graduate from Excel, you do Excel templates. Okay, so it's still manual. You're doing it by hand. You're putting the data from the system, typing up the data, making mistakes, and those kind of things. On the other end, you have very, very, very sophisticated statistical tools that, and CAD softwares, a very sophisticated system can do visualization, can do complex calculation, complex dynamics, thermal, force, and other scenarios it can do for you. Very, very complex. So you have, on one hand, you have very rudimentary, very basic solutions. On one hand, you have very complex, robust solution. Okay, neither of them are really good fit for daily life, for 90% of the things that you want to do on a daily life. I mean, as we were saying earlier, as an engineer, what we want to do, we want to build nice products. We don't want to spend our day doing these calculations, update the calculations over and over, right? So you have one hand, you can do things very fast manually, but have a chance of making mistakes, having a chance of not doing the calculation right. On the other hand, you can do everything right, but it is overkill. You have a lot of work to do to get to where you want, right? So I'm going to use that metaphor. It's like, going to your grocery store. What do? You take your car to go to the grocery store. Neither bike nor airplane is a good solution for that kind of short distance to do something. And that's exactly what we are doing with Tolerance 360. It's the perfect fit for the things, the calculations that you want to do most of the time. So.
Excellent. I like that. You don't need a bike or an airplane to go to the grocery store.
Exactly. I mean, just to make it simple and make it relatable. That's what we are trying to do. Something that someone can use, an engineer can use on a daily basis to solve the problem. In fact, at one of our clients, 200 some engineers are using this system on a daily basis. And they do have other softwares. Many other softwares. Several different CAD systems. They do have other statistical tools. That they can use, but still, it is a favorite tool to solve problem on a daily basis. So.
Awesome. Well, and Tolerance 360 is integrated with tools that engineers are already using.
Actually, our tool is very easy to learn, very easy to use, and it is integrated with actually Excel. For a couple of reasons. One is Excel is something that they're already using and already accustomed to. Plus, our tool is kind of like much suited for Excel rather than any statistical CAD software. So we wanted to kind of differentiate ourselves, not line up with CAD softwares and bolt on, we did not want to integrate or bolt on onto a 3D software because really we didn't see the need for it. Our software is much more aligned with Excel. A lot of times they might want to check the result manually just to see if our result is right. So it is an Excel based software. Maybe we should ask, have you ever had a situation where you found a mistake after your design went into production, or worse even, after your product went to the market and you had to recall the product, because a calculation, tolerance calculation mistakes that was discovered way later, Have you had a situation where your team of engineers worked days and days to make sure all the calculations are right? Have you had a situation where you spent 3 days to make a change and update all the calculations? Have you had a situation where you felt like, or maybe you have spent half a day just to do a tolerance calculation? Some of those questions, do you have many tolerance calculations? That's another scenario. See, if you have only 5 calculations and you have to do this, one time a year, this is not the software for you. You can do it manually by hand. On the other extreme of it, if you have 500,000 calculations, 2,000, 5,000 calculations, and many different parts, if you are in an industry that is regulated, like FDA regulations, you need a lot of documentation. Yeah, you have to ensure quality. If you have a situation where you have many different parts, and also the parts are needs to be precise, it's called precision engineering, field, then that is another scenario where our software is valuable.
Yeah, and just back to the, learning tolerance analysis, our tool is very intuitive. It does not take very long to learn how it works. You basically, the data is loaded into the database in the system, and if you want to add a part to a stack, you click on it and you find the part and it's already there. You don't have to type any information. That helps eliminate some of the manual errors that can be created. And if you're a younger engineer that hasn't done a lot of tolerance analysis, this is a great tool to start with, because it's very visual, and it makes it very easy to see how things are working. And there's also other tools built into it where you can kind of play around with the numbers and try different things and see, is this going to work, or do I need to do something else? So you can't make too many mistakes with the software the way it's designed, and that we did that on purpose. We wanted to eliminate that aspect that you do see with some other solutions that are out there.
Like David and Subrata told, like making it error-free by not editing or interacting with the data that's already there is one of the main features. And other than that, I think one of the main features is this, like we have a database which has like all the versions of the parts and things already in the database. For example, a CAD might have like a file which has to be like saved manually by a user, and like he has to keep track of it in like different folders for different versions. But in our case, we have a database. We can have it in have all the versions in the database, and even create like reports like very easily, like in one click, and we can have like customizable reports according to our needs, and like keep on using it. That's also one of the main features that saves a lot of time in our software.
Exactly. Thank you, Vishnu. Yeah, for the clarification. Yeah. So yeah, I mean, at the center of the software. I mean, in the beginning, I was kind of mentioning, we are looking at the world from a data standpoint. We are not looking at the world from a design standpoint. So design is the job of an engineer, whereas we take the job of managing the data. Okay, so our software is a very data intensive. At the center of it, we have a centralized database that many engineers can use at the same time. It's a collaborative effort in most cases anyway. So there is a single version of truth, single repository, single database. But what the database does is that, the metaphor is, like if you want to go to the moon, the car is not enough, airplane is not enough. You need a different technology, rocket, you need that. And the same thing with database. If you have a database in the center of it, it can do amazing things for you. Okay, so all of a sudden we can now keep track of things. All of a sudden we can now log things. All of a sudden we know who made changes, when they made changes, what changes that they made. We can also do what if scenario analysis all of a sudden, because if you want to change the size of a part from 3 millimeter to 5 millimeter, what that's going to do to 500 other calculations, the whole big system that you have. If you want to change the size of a hole or a screw, what's this going to do with the 500 other places in the whole system? You can know that immediately, within a few seconds. And that's the beauty of a database, which is a much different technology than if you have to do it, of course, manually or by a file-based system, what Vishnu was mentioning, or any other way, right? So that's what we are trying to get to. Again, the one metaphor I always use is that the reason we had to think differently and do things differently is that, like, if you look at a lamp, you know, you can improve the lamp, continuously improve and make a bigger, better lamp, you know, bigger, better, you know, light or light source. But improving the lamp does not get you to the light bulb. The light bulb is a different technology, and it has changed the whole world and has lit up the whole world, right? So that's what we are doing with Tolerance 360.